What if the last ice age wasn't just a climatic shift, but a cataclysm that wiped out the world's earliest civilizations? For millions of years, Earth has cycled through ice ages, but the one that ended just 11,000 years ago stands apart. Its abrupt collapse launched the age we live in, and left behind whispers of floods, destruction, and realms buried beneath melting ice. Across cultures, ancient legends speak of survivors, gods, and vanished societies. Archaeology reveals structures seemingly older and more advanced than recorded history allows. This documentary dives into the mystery, the sudden end of the Ice Age, the devastation it unleashed, and the possibility that an entire chapter of humanity vanished with it. You'll hear the legends, see the evidence, and decide for yourself what the Ice Age really erased. Around 12,800 years before the present era, the Earth experienced a sudden and dramatic climatic collapse. This period is known as the Younger Dryas, and it marked the final great interruption at the close of the last ice age. For thousands of years, the planet had been emerging from the grip of massive glaciation. Temperatures were gradually rising, ice sheets were retreating, and ecosystems were beginning to stabilize. Human communities, still largely hunter-gatherers, were adjusting to these changing conditions. Then, in what appears to have been a very short span of time, the warming was interrupted. A rapid descent into cold conditions swept across much of the northern hemisphere, plunging vast regions back into near-glacial environments. The Younger Dryas lasted for roughly 1,200 years. During this interval, the Earth's climate regressed toward the severe cold of the preceding ice age. Temperatures in parts of Europe and North America dropped dramatically. Glaciers that had been retreating stabilized, and in some areas they advanced once more. The return of frigid conditions profoundly disrupted both ecosystems and early human society. What had seemed to be a steady movement toward warmer, more stable climates was suddenly reversed. The cause of this climatic collapse has been the subject of extensive debate. Traditional explanations often focus on natural changes in the circulation of ocean currents. According to this view, vast amounts of fresh meltwater from retreating glaciers may have poured into the North Atlantic. This influx of fresh water could have disrupted the system of currents known as the Atlantic Meridional Overturning Circulation, which carries warm, tropical waters northward. If this conveyor weakened or shut down, northern regions would have cooled rapidly, while the southern hemisphere experienced different shifts. This remains one of the most widely accepted scientific explanations. However, beginning in the late 20th century, an alternative theory gained attention. This idea is known as the Younger Dryas impact hypothesis. It suggests that the climatic collapse was triggered not only by shifts in ocean circulation, but by a sudden and catastrophic event, the explosion or impact of a celestial object. According to this hypothesis, either a large comet or a fragmented meteor entered Earth's atmosphere and struck with immense force around 12,800 years ago. The consequences of such an event would have been devastating. The impact or series of impacts could have caused enormous wildfires, massive flooding, destructive airbursts, and the rapid cooling of the atmosphere. According to proponents of the hypothesis, the Younger Dryas cataclysm represents a pivotal turning point in human prehistory. The sudden drop in temperature would have altered landscapes on a continental scale. Megafauna already under stress, such as mammoths and mastodons, would have faced even harsher conditions. Human groups that depended on large game, or that were beginning to experiment with more settled forms of subsistence, would have encountered severe challenges. Croplands and wild plants suitable for gathering could have been devastated by the abrupt change in climate. This theory also carries a deeper and more controversial implication. Some researchers and popular writers have suggested that the Younger Dryas cataclysm may have erased early civilizations. In this view, advanced cultures may have existed before 12,800 years ago, only to be destroyed by the sudden return of glacial conditions. If true, this would mean that the human story prior to the rise of the known ancient civilizations, such as those of Mesopotamia or Egypt, may have been more complex than traditionally believed. Writers such as Graham Hancock and Randall Carlson have brought this interpretation to wide public attention. They argue that myths of floods and cataclysms, preserved in traditions around the world, may be distant memories of this destructive period. In their narrative, the Younger Dryas becomes the great dividing line, a point zero when earlier civilizations were swept away, leaving later societies to begin anew once the climate stabilized. But if the Younger Dryas was triggered by a sudden cosmic event, then scientists ask, where is the proof? Over the past few decades, researchers have pointed to unusual physical traces found in soils and sediments around the world. These traces are small in size, but they suggest events of enormous scale. Nanodiamonds are tiny crystals of carbon, measured in nanometers, far smaller than the width of a human hair. They are important because they often form under extreme heat and pressure, such as during meteor impacts or massive explosions in the atmosphere. Some researchers claim to have found these nanodiamonds in sediment layers that date to the beginning of the Younger Dryas, about 12,800 years ago. Their presence is taken as a possible sign of a violent encounter between Earth and a comet or meteor. If true, it would mean that a cosmic strike left behind not only destruction, but also a microscopic fingerprint locked into the soil. Another piece of evidence often mentioned is iridium. This is a rare element on Earth's surface, but it is much more common in meteorites. Scientists studying the boundary between different geological layers sometimes look for spikes in iridium concentration. A famous example is the global iridium layer connected to the impact that ended the age of dinosaurs. In the case of the Younger Dryas, some studies suggest there are small but unusual peaks of iridium in sediments from North America, Greenland, and other regions. Supporters of the impact hypothesis argue that this could be a trace left behind by a cosmic object that exploded in the sky or struck the Earth. Critics, however, note that iridium can also come from volcanic activity or other natural processes, and they caution that the findings are not always consistent across sites. A third line of evidence comes from layers of soot and ash, sometimes called black mats. These are dark sedimentary bands found in several archaeological and geological sites dating to the start of the Younger Dryas. They appear to record massive fires that swept across landscapes. Proponents of the impact theory argue that such widespread burning would be consistent with a comet exploding in the atmosphere, releasing enough heat to ignite forests and grasslands across continents. If true, this would explain the sudden and simultaneous appearance of dark layers in soils thousands of kilometers apart. Yet, as with nanodiamonds and iridium, other scientists argue that natural fires linked to climate shifts could also account for these findings. Taken together, these three types of evidence are used to support the idea that a sudden impact event occurred at the start of the Younger Dryas. And yet, these are not the only clues that point toward a cataclysm. There are also forms of evidence that are not purely scientific, and while they raise more questions than answers, they too demand attention. In the hills of southeastern Turkey lies one of the most remarkable archaeological discoveries of the modern age. This site, known as Göbekli Tepe, has changed how scholars think about the beginnings of human civilization. First uncovered in the 1960s and later studied in detail by German archaeologist Klaus Schmidt in the 1990s, Göbekli Tepe revealed circles of massive stone pillars arranged in rings. Each pillar is decorated with carvings of animals and abstract symbols. Radiocarbon dating shows that the site is about 11,600 years old, which makes it far older than Stonehenge in Britain or the pyramids in Egypt. For many, Göbekli Tepe is the earliest known temple complex in the world. The stones of Göbekli Tepe stand as high as 5 meters and weigh several tons. One of the most famous is Pillar 43, often called the vulture stone. On its surface are a vulture with outstretched wings, a scorpion, several birds, and a round disc carried in the claws of one of the animals. But these symbols have inspired different interpretations. Mainstream archaeology usually views them as part of ritual imagery. The vulture, for example, could represent death, as vultures were associated with the sky burials of early people. The scorpion may symbolize danger or transformation. Together, the symbols might have been part of a story connected to shamanic visions or beliefs about life and death. However, in 2017, a very different interpretation was proposed by Dr. Martin Sweatman and his team at the University of Edinburgh. They argued that the carvings on the vulture stone are not simply ritual symbols, but are actually astronomical records. By using computer programs to reconstruct the ancient sky, they match the animals on the stone to constellations. In their view, the scorpion corresponds to the constellation Scorpio, the bird may represent Sagittarius or Aquila, and other symbols match Virgo and Capricornus. The circular disc carried by the bird, they suggested, could represent a comet or a fragment of a comet. When they tested this alignment, they found that the sky pattern best matched the year 10,950 BC, a date that coincides with the beginning of the Younger Dryas, a period of sudden and catastrophic cooling. According to Sweatman and his colleagues, the vulture stone might be the oldest record of a comet impact ever discovered. They suggest that Göbekli Tepe served as an early observatory where people carefully tracked the sky and carved down the memory of a disaster that shaped their world. This idea directly connects the site to the Younger Dryas impact hypothesis, which proposes that a comet or fragments from a meteor swarm struck the Earth about 12,800 years ago, causing wildfires, flooding, and a dramatic drop in temperatures. Not all scholars accept this interpretation. Archaeologists working at Göbekli Tepe caution that linking animal carvings directly to constellations may be too speculative. They argue there is no clear evidence that people of that era possessed advanced astronomical knowledge. Critics also note that the carvings can have multiple meanings and that the leap from symbolic art to precise star maps is not well supported. Still, the theory has attracted much attention because of how closely the date matches the start of the Younger Dryas event. Some researchers go even further. For example, Graham Hancock sees the vulture stone as evidence that survivors of a lost civilization carried their knowledge into the early Neolithic world. According to this view, Göbekli Tepe was not the creation of simple hunter-gatherers, but was instead influenced or even built by people who preserved advanced skills after the end of the Ice Age. This idea connects to a larger question. How could groups of hunter-gatherers, who had not yet developed farming or permanent villages, have created such a monumental site? The scale of Göbekli Tepe requires planning, organization, and labor coordination that seems far beyond what small nomadic bands were thought capable of. Some scholars now think that building the site may itself have sparked the development of farming and settled life, as the need to feed large groups of workers encouraged the first experiments with domesticated plants. But for those who see the site as evidence of a forgotten past, the answer lies in knowledge passed down from an earlier, more advanced culture. The age of Göbekli Tepe only deepens the mystery. The site is at least 6,000 years older than the Egyptian pyramids. To put this into perspective, more time separates Göbekli Tepe from the pyramids than separates the pyramids from us today. That span of nearly 12,000 years challenges our understanding of when and how human civilization began. If Göbekli Tepe was indeed a temple complex, then it was built long before the rise of writing, cities, or even widespread agriculture. For some, this timeline is evidence that we may have underestimated the achievements of Ice Age peoples, or that their skills were the legacy of civilizations that came before them. As striking as Göbekli Tepe is, it is not alone. Around the world, there are other ancient structures that seem older or more advanced than expected, but this time under the sea. There is an idea that the world we see today is only part of the story of our past. Many coastlines that once held life, settlements, and perhaps even cities are now hidden under the sea. During the last ice age, sea levels were much lower because much of the planet's water was locked up in ice sheets. When the ice melted, the seas rose by about 120 meters. This rise flooded vast areas of land that people once called home. If early human communities built villages, shrines, or even larger centers along those ancient coasts, much of that evidence would now lie underwater. So where can we actually find these underwater clues? The answer is pretty simple. All over the world. One of the most famous examples of a drowned world is Doggerland. This was a vast stretch of land that once connected Great Britain with mainland Europe. Between 10,000 and 7,000 years ago, it was home to rivers, lakes, marshes, and fertile hunting grounds. Archaeologists believe it supported thriving Mesolithic communities of hunters and gatherers. Evidence of Doggerland has come to light slowly. Fishermen in the North Sea have pulled up bones of mammoths, lions, and even humans, along with stone tools and weapons. These finds show that the land was once full of life. Today, with the help of seismic surveys and computer simulations, scientists have been able to map the ancient rivers and valleys that ran across it. But Doggerland did not last. As the climate warmed, glaciers melted and the seas rose. Over time, the land shrank into low-lying islands before disappearing completely beneath the water. Around 6,200 BC, a massive submarine landslide off the coast of Norway, known as the Storegga Slide, may have sent a tsunami crashing into what remained of Doggerland. Some researchers suggest that this flood destroyed the last habitable areas, forcing survivors to migrate inland. Because of its sudden disappearance, some have called Doggerland the Atlantis of Europe. How many other Doggerlands might lie hidden under the seas of the world, carrying with them forgotten chapters of human history? Far from Europe, off the coast of India, lies another site that connects myth with archaeology. The ancient texts of Hindu tradition describe a city called Dvarka, built by Lord Krishna. According to the story, it was a rich, fortified city with walls, gates, and a bustling harbor. But after Krishna's departure from Earth, the sea swallowed the city, leaving only legends behind. In the 20th century, marine archaeologists began to explore the waters near modern Dvarka in Gujarat. Starting in the 1960s and continuing through later decades, divers discovered stone blocks, anchors, and structures that suggested the presence of an ancient port. Some finds included large walls and circular foundations. These discoveries gave new life to the idea that the myth of Dvarka might be based on a real place. Dating the site has been difficult. Some artifacts suggest it may be more than 9,000 years old, which would make it older than the earliest known Indian cities. Other studies point to younger dates, closer to 3,000 or 4,000 years ago, fitting better with known patterns of early urban development in the region. The wide range of possible ages is one reason the site remains controversial. Still, the evidence is striking. The presence of stone anchors in particular suggests that Dvarka was once an important harbor city. Its structures, if confirmed, could match the descriptions in the Mahabharata of a fortified settlement built on reclaimed land by the sea. In recent years, renewed explorations by the Archaeological Survey of India and the Indian Navy have continued to bring attention to the site. There are even plans to make the ruins accessible through submarine tourism, showing how much fascination this underwater world still holds. Another mysterious site lies in the waters off the island of Yonaguni, Japan. Discovered in 1995 by a diver, the Yonaguni Monument appears as a massive set of stone structures lying beneath the waves. The site has broad platforms, sharp angles, and what look like staircases and terraces carved into the rock. Some observers describe streets, crossroads, and even features that resemble gateways and pillars. Those who argue the site is man-made see it as the remains of an ancient city, perhaps built 10,000 years ago when sea levels were lower. They point to holes in the rock that may have been made by tools, right-angled joins between stone blocks, and markings that resemble symbols. Professor Masaki Kimura, a marine seismologist, has been one of the leading voices supporting this interpretation. He believes the monument shows signs of human construction, possibly by the Jaman people who lived in Japan during that era and developed early pottery. Other scholars are more cautious. Geologist Robert Schoch and others argue that the formations are natural, shaped by earthquakes and erosion. They point to similar natural rock formations around the world, such as the Giant's Causeway in Ireland. According to this view, the steps, terraces, and sharp angles may simply be the result of tectonic fractures and natural processes. Still, for many, the coincidences are just too big to ignore. Next, in India, there is another story of temples claimed by the sea. The coastal town of Mahabalipuram is famous for its shore temple, but local legends speak of 7 magnificent pagodas built along the coast. According to the tale, 6 of these shrines were swallowed by the ocean, leaving only one standing. For centuries, the story was dismissed as myth. But in 2002, after a powerful tsunami pulled back the waters, explorers noticed the outlines of stone structures offshore. Subsequent dives by the Archaeological Survey of India confirmed that large walls, broken pillars, and carvings lay beneath the waves. Divers even reported seeing statues, including a massive figure of Lord Vishnu, lying in repose. Some scholars view these findings as evidence that the 7 pagodas legend had a real foundation. The temples may have been destroyed by ancient tsunamis or slow sea level rise. The scale of the submerged ruins suggests that Mahabalipuram was once an even greater religious center than previously thought. For others, the underwater remains point to something larger. The possibility that advanced coastal settlements, perhaps dating back to earlier periods, were erased during the turbulent transitions after the Ice Age. Far across the ocean, near the Bahamas, lies one of the most debated underwater features, the Bimini Road. Discovered in 1968, it is a long line of stone blocks stretching nearly a kilometer. To some divers, the blocks resemble a paved road or seawall with rectangular shapes that look too regular to be natural. Proponents of the man-made theory argue that the Bimini Road is evidence of an ancient maritime culture, possibly linked to civilizations destroyed at the end of the Ice Age. They suggested it might even be a remnant of a larger forgotten world, a sign that advanced builders once lived in the Caribbean thousands of years ago, earlier than accepted history allows. Geologists, however, counter that the stones are natural beach rock created when sediments hardened and later fractured into geometric patterns. According to this explanation, the resemblance to masonry is a coincidence of nature. Although the scientific explanations for each of these sites may sound logical, for some people that's just not enough. It feels strange that so many underwater structures have been found, advanced in design, comparable to what we see in known history, yet far older. And on top of that, who knows how many more of these hidden structures are still lying out there in the depths, waiting decades to be discovered, and even more decades before we can truly decipher them. But what if all of this isn't a coincidence? What if all these underwater structures point toward another legend? One first told by the Greek philosopher Plato. Around 360 BC, Plato described Atlantis in two of his dialogues, Timaeus and Critias. In these texts, Atlantis was portrayed as a powerful island empire located beyond the Pillars of Hercules, which is the ancient name for the Strait of Gibraltar. According to Plato, the Atlanteans once ruled vast territories and posed a threat even to Athens, before their civilization vanished in a single day and night of earthquakes and floods. Plato's account was not framed as mythology in the traditional Greek sense. Rather, it was presented as a historical memory, preserved by Egyptian priests and passed on through Solon, the Athenian statesman. Because Plato was both a philosopher and a storyteller, scholars continue to debate whether he intended Atlantis to be an allegory about hubris and the downfall of empires, or whether he was relaying fragments of an older tradition. What is certain is that this single story gave rise to centuries of speculation about whether Atlantis had once been a real place on Earth. When we place Plato's story against the backdrop of the last Ice Age, new dimensions of interpretation emerge. During the peak of the Ice Age, which ended about 11,700 years ago, sea levels were more than 100 meters lower than today. Vast stretches of land that are now beneath the sea were then dry, forming coastal plains that could support human settlement. As the great ice sheets melted at the end of the Younger Dryas period, enormous volumes of water entered the oceans. Coastlines shifted dramatically and entire regions that had once been habitable were submerged. This geological reality provides a context for Plato's tale. If Atlantis was described as sinking beneath the sea around 9,600 BC, that date aligns closely with the final stages of the Ice Age. The overlap between Plato's timeline and this period of dramatic climate change has encouraged some to connect the story of Atlantis with the memory of real events when rising seas erased entire coastal landscapes. From this perspective, Atlantis may not represent a single city or empire, but a symbol of the many settlements lost to the waters at the end of the Ice Age. Still, attempts to pinpoint a physical location for Atlantis have taken many forms. Some researchers look to the open Atlantic Ocean, arguing that Plato's placement of the island beyond the Pillars of Hercules points westward. In this context, the Azores, a group of volcanic islands belonging to Portugal, are sometimes proposed as remnants of the Atlantean highlands. Because the Azores rise steeply from the ocean floor, some have suggested that they may once have been part of a larger landmass, partially submerged by post-Ice Age sea level rise. The idea of the Azores as the mountain peaks of Atlantis was popularized in the late 19th century by writers such as Ignatius Donnelly, whose book Atlantis, the Antediluvian World, tied the myth to theories of a global flood. However, geological evidence shows that the Azores have been islands for millions of years, casting doubt on their connection to a vanished Ice Age continent. Other proposals place Atlantis far from the Atlantic. A particularly striking suggestion is that the lost civilization once lay beneath Antarctica. This idea gained traction in part because of maps from the early modern period, which some claim depicted the Antarctic coast free of ice. Advocates argue that during the Ice Age, parts of Antarctica might have been ice-free and habitable, hosting an advanced society later buried beneath the expanding ice sheets. This theory resonates with the broader fascination around Antarctica as a potential repository of lost knowledge, a theme explored in modern speculative works. Yet, mainstream science strongly rejects the idea of Ice Age civilizations in Antarctica, noting that the continent was already heavily glaciated for millions of years, long before humans could have settled there. A third line of speculation takes us to the Sahara Desert, specifically to a geological feature known as the Richet structure, or the Eye of the Sahara. Located in Mauritania, this massive circular formation measures nearly 40 kilometers across and is clearly visible from space. Its concentric rings have led some to compare it with Plato's description of Atlantis, which spoke of alternating circles of land and water around a central island. Supporters of this view argue that during the Ice Age, when the Sahara was greener and wetter than today, the Richet structure might have been the center of a thriving society, later destroyed by desertification and shifting climates. While the resemblance between the Richet structure and Plato's text is intriguing, geologists explain the formation as a natural result of erosion, not human construction. No archaeological evidence has yet linked it to an advanced prehistoric culture. What unites these different theories, whether in the Atlantic, Antarctica, or the Sahara, is their connection to the end of the Ice Age. This was a time of great upheaval, when environments transformed rapidly and humans faced the challenge of adapting to new coastlines, changing weather, and the flooding of once fertile lands. In this context, Plato's Atlantis can be seen as part of a larger human memory of worlds lost to water. What is interesting is that many civilizations in very different parts of the world tell stories of a great flood. These stories are not identical, but they all share a common theme: a powerful flood that destroys most of humanity, leaving only a few survivors who carry life into the next age. Scholars have long noticed that such myths often appear to reflect memories of real events, and some suggest they may recall the dramatic environmental changes that followed the end of the Ice Age. One of the best-known accounts is the biblical story of Noah. In the book of Genesis, humanity has become corrupt, and God decides to cleanse the world with a flood. Noah is chosen to build a large ark, a wooden vessel able to survive the rising waters. On board, he gathers his family and pairs of animals, preserving the living world from destruction. After 40 days and nights of rain, the waters eventually receded, and the ark came to rest on a mountain. Noah and his descendants then repopulate the earth. While this story is framed as a moral lesson in the religious tradition of the ancient Hebrews, It is also a vivid description of survival against overwhelming natural forces. Centuries before the Hebrew text were written, the Mesopotamian people also told of a great deluge. In the Epic of Gilgamesh, one of the oldest known works of literature, we find the tale of Utnapishtim. He is warned by the god Ea that a divine flood will soon destroy humanity. Like Noah, he builds a great boat, brings his family, and preserves animals and seeds. When the waters finally settle, his vessel comes to rest on a mountain. In South Asia, the Hindu tradition preserves a different version of the same theme. The story tells of Manu, the first man, who is warned by a small fish about a coming flood. The fish asks for his protection, and in return promises to save him from the disaster. Manu raises the fish, which grows enormous, and later reveals itself as an incarnation of the god Vishnu. The divine fish instructs Manu to build a boat, and when the flood arrives, the fish pulls the boat to safety with its horn. From Manu, life continues into the New Age. Far away in the Americas, indigenous peoples also remember great floods and world-ending catastrophes. In the traditions of the Maya, there are stories that humanity has gone through several creations and destructions. One of these destructions involved a massive flood, wiping away an earlier race of humans before a new world was created. The Hopi, a Native American people of the Southwest, also tell of previous worlds that were destroyed because humans lost harmony with the order of life. According to their tradition, one of these worlds ended in a flood, with only a small group of survivors escaping to begin again. When we place these myths side by side, a pattern becomes clear. Although the stories differ in their details, at the heart of each one lies humanity surviving a great catastrophe and being forced to begin again from scratch. If we now take into account archaeological evidence, we see that the oldest known monumental structures are dated to around 11,000 to 12,000 years ago. This period aligns precisely with the end of the last ice age. In other words, for many scientists, this is a strong enough reason to truly believe that this period marked a reset of human civilization. There is, however, one theory about who these survivors really were, who carried the responsibility of ensuring that humanity would continue after the great catastrophe. According to many, the figures remembered in myths as gods may not have been divine beings in the supernatural sense, but rather human survivors of advanced cultures that existed before the end of the Ice Age. When their own world was destroyed, these survivors may have preserved fragments of knowledge and then shared it with the scattered groups of hunter-gatherers who remained. The idea is speculative, but it helps explain a puzzle in human history. The sudden rise of complex skills, such as large-scale building, astronomy, and organized law, in the centuries that followed the Ice Age. Archaeological records show that for tens of thousands of years, human groups lived mostly as nomadic hunters and gatherers. Their tools were simple, their shelters temporary, and their social structures small in scale. Then, in a relatively short time, we see the appearance of monumental architecture, precise astronomical observations, and the first organized states. The leap seems so great that some researchers suggest it may not have been an entirely natural progression. Instead, it could reflect the transfer of knowledge from those who had lived before the floods and ice collapse. Across different traditions, we find myths of gods who arrived from the sea or from distant lands after a great disaster. In Mesoamerican culture, the Maya and other peoples told stories of deities connected with water, floods, and rebirth. Their gods often carried tools of knowledge, teaching humans how to grow crops, measure time, and observe the heavens. Similarly, in ancient Egypt, there are traditions of gods who came from across the waters. Figures such as Osiris were not only associated with the underworld, but were also described as bringers of order, agriculture, and civilization. In both cases, knowledge appears as a gift brought by outsiders who potentially arrive in the aftermath of destruction. For those who support the theory of Ice Age survivors, such parallels are more than coincidence. They see them as memories of real people, groups who endured the climate shifts and later appeared to less advanced societies as beings of immense power. To a community of hunters living in small camps, someone who could explain how to measure the stars or irrigate crops would indeed seem godlike. These encounters may have been preserved in myth, where human teachers slowly transformed into divine figures over centuries of retelling. This idea also intersects with one of the most enduring mysteries of human history, the origins of the Sumerians. Around 4000 to 3000 BC, in the fertile lands of Mesopotamia, the first urban civilization emerged with extraordinary speed. The Sumerians developed writing, mathematics, astronomy, and complex laws earlier than any other known culture. Their city-states featured monumental temples, intricate administrative systems, and organized trade networks. What puzzles many scholars is how all of these elements appeared almost simultaneously, with little evidence of a long period of gradual development. Sumerian myths themselves speak of earlier epochs, in which the world had been destroyed and remade. They describe great floods, cosmic battles, and times when humans lived under the direct guidance of powerful beings. These beings, remembered as gods, were often said to have given humanity the tools of civilization, language, farming, building, and law. The Sumerians did not present themselves as the inventors of culture, but as receivers of it, inheriting knowledge from those who came before. This has led some researchers to suggest that the Sumerians may have preserved the memory of earlier, now lost peoples. In this interpretation, the gods of Mesopotamia were not otherworldly beings, but echoes of human survivors who transmitted advanced skills after the environmental crises of the late Ice Age. Over time, as the memory of those survivors became distant, they were remembered in myth as divine figures who descended to guide humanity. The suddenness of Sumerian achievement has long fascinated historians. Cuneiform writing, one of their greatest contributions, appears fully formed, rather than slowly evolving from earlier symbols. Their understanding of mathematics included place value and geometry, which they used to calculate land, build canals, and track celestial movements. In astronomy, they recorded detailed star maps and developed calendars tied to both lunar and solar cycles. They also established some of the first legal codes, setting rules for trade, property, and social conduct. Each of these advancements is remarkable on its own, but together they represent a profound transformation in human society. From a conventional academic standpoint, these achievements can be explained as the product of favorable geography and human creativity. The rich soils of Mesopotamia, nourished by the Tigris and Euphrates rivers, allowed for surplus food, which supported population growth and urbanization. Surpluses freed some individuals from farming, allowing them to specialize as scribes, builders, or priests. Innovation built upon innovation until complex systems emerged. Yet for those who support the theory of Ice Age survivors, the sudden clustering of these skills remains striking. They claim that it resembles less a slow evolution and more a sudden inheritance of forgotten knowledge. In Mesoamerica, Gods like Quetzalcoatl were remembered as civilizers who brought agriculture, law, and order after earlier worlds were destroyed. In Egypt, gods like Thoth were credited with giving humanity writing and mathematics. In Mesopotamia, the god Enki was said to have granted wisdom and guided humans through floods and disasters. Similar to the Sumerians, the ancient Maya also believed that history was not one straight line, but a series of repeating ages. Their calendar was one of the most advanced of the ancient world. According to Mayan tradition, there were 4 worlds before ours, each destroyed in turn. These worlds ended in fire, flood, or other disasters, wiping out the people who lived in them. The present era in Mayan belief is the 5th world. It began after the last great destruction, and it is the time in which we now live. This idea of recurring worlds shows how deeply the Maya linked human destiny with cycles of creation and catastrophe. The structure of the Mayan calendar itself reinforced this way of thinking. The 260-day Tzolk'in cycle was joined with the 365-day Harb year to create the calendar round, a cycle of 52 years. Beyond this, the long count calendar allowed the Maya to track vast stretches of time, stretching thousands of years into the past and the future. In their myths, these cycles were not only about measuring time, but about preparing for the possibility that history itself could repeat. For them, the destruction of one age and the birth of another was part of the natural order. In the 20th century, a very different voice revived this theme of recurring catastrophes. Edgar Cayce, often called the Sleeping Prophet, became famous for the predictions he gave while in trance states. One of his most striking ideas was that cataclysms occur in cycles, repeating across the ages. Cayce believed that the Earth undergoes sudden and violent changes that reshape continents, sink islands, and bring new lands to the surface. He even predicted that the lost land of Atlantis, which he claimed had sunk thousands of years earlier, would rise again in the 20th century. Cayce described these events as part of a larger cosmic rhythm. He spoke of shifts in the Earth's poles, violent earthquakes, and massive floods that would erase entire coastlines. While his time frames did not come to pass as he described, his vision of cyclical destruction left a lasting mark on modern interpretations of ancient history. For many who followed his work, Cayce's ideas echoed the myths of civilizations like the Maya, who saw human history as shaped by repeated endings and new beginnings. In more recent decades, researchers outside the mainstream have taken up similar themes. Randall Carlson, a geological explorer, is one of the most prominent. Carlson argues that Earth is periodically struck by cosmic debris, especially from the Taurid meteor stream. According to his work, every few thousand years, the planet passes through dense regions of this cometary swarm, increasing the chance of devastating impacts. He connects these encounters to massive floods, sudden cooling events, and widespread destruction recorded in both geology and myth. Carlson's views link directly to the Younger Dryas period. He believes this was not a gradual climate shift, but the result of impacts or explosions from space. The black matte sediment layer full of nanodiamonds and magnetic particles is for him evidence of these sudden events. He sees the Younger Dryas as the most recent in a series of recurring cataclysms, each one leaving behind both physical traces in the landscape and cultural memories in myth. Graham Hancock also talks about advanced cultures that may have existed before the Younger Dryas, only to be destroyed by the cataclysm that ended the Ice Age. In his view, survivors of that disaster carried fragments of their knowledge into later societies, planting the seeds for the sudden appearance of agriculture, astronomy, and monumental architecture. But what does science say about this? Do we really live in a world defined by endless cycles of catastrophe? The most important figure in science who explained the pattern of Earth's ice ages was Milutin Milankovic, a Serbian mathematician and astronomer working in the early 20th century. His ideas are now called the Milankovic cycles. He showed that small, predictable changes in the Earth's orbit and tilt control the timing of ice ages and warm periods. These changes happen slowly, over tens of thousands of years, but they are powerful enough to reshape the planet's climate. Milankovic focused on three main cycles. The first is eccentricity, which measures how circular or oval Earth's orbit is. Over a cycle of about 100,000 years, the orbit shifts from nearly round to slightly more stretched. This affects how much solar energy reaches Earth at different times of the year. The second cycle is obliquity, the tilt of Earth's axis. Today, the tilt is about 23.4 degrees, but it shifts between 22.1 and 24.5 degrees in a cycle of about 41,000 years. A greater tilt makes summers hotter and winters colder, especially at higher latitudes. The third cycle is precession, often called the wobble of Earth's axis. It is like the slow movement of a spinning top, and it shifts the direction of Earth's tilt over a cycle of roughly 26,000 years. Precession changes when in the year Earth is closest to the Sun, which alters the strength of the seasons. Together, these three cycles control how sunlight is distributed on Earth. What matters most is the summer sunlight in the northern hemisphere, because this is where large ice sheets grow and melt. When summers are cool, ice remains and glaciers expand. When summers are warm, ice melts and ice sheets retreat. Over hundreds of thousands of years, this balance has created the rhythm of ice ages and interglacials that scientists can see in ice cores, ocean sediments, and fossil records. The evidence for these cycles is now strong. In the 1970s, deep-sea cores revealed repeating patterns of oxygen isotopes that match the timing predicted by Milankovic's theory. Since then, studies of Antarctic ice cores and ocean sediments have confirmed that Earth's climate follows these orbital rhythms. Over the last million years, ice ages have tended to last about 100,000 years, interrupted by shorter warm periods like the one we live in today. This pattern matches the eccentricity cycle, but it is also influenced by the tilt and precession of Earth's axis. Scientists have also used these records to predict the future. Based on natural cycles alone, Earth should remain in the current interglacial for thousands of years. Some studies suggest the next ice age would normally begin in about 10,000 years. However, human activity has already changed this outlook. The release of greenhouse gases has raised global temperatures and may delay the natural return of ice sheets far into the future. In other words, while orbital cycles still operate, the climate system is now being reshaped by forces outside those natural rhythms. Precession, the 26,000-year cycle of Earth's wobble, plays a key role in this story. Today, Earth reaches perihelion, its closest point to the Sun, in early January, during the southern hemisphere's summer. This makes southern summers slightly warmer and southern winters slightly colder. In about 13,000 years, this situation will reverse. Earth will be closest to the Sun during northern hemisphere summer, making northern summers hotter and winters milder. Over long spans of time, this cycle changes how much ice survives each summer and helps drive the advance and retreat of glaciers. The concept of orbital forcing, first set out by Milankovitch and later confirmed by decades of data, shows that Earth's ice ages are not random disasters. They are part of a natural system, predictable in broad outline and governed by the geometry of Earth's orbit. While myths and alternative theories speak of sudden cataclysms, the scientific explanation emphasizes slow, repeating changes driven by the Sun, Earth, and gravity. By studying these cycles, scientists have built a timeline of past climate shifts, stretching back millions of years. They have shown that every glaciation of the last 900,000 years follows the same broad pattern. Ice sheets expand when summer sunlight in the north is weak, and they retreat when summer sunlight is strong. This view does not rule out that sudden events, such as volcanic eruptions or asteroid impacts, can influence climate, but the foundation of the Ice Age cycles rests on orbital mechanics. Today, researchers continue to refine these models. They use advanced computer simulations to test how eccentricity, tilt, and precession interact with other parts of the climate system, such as ocean currents and greenhouse gases. These studies suggest that orbital cycles set the pace of the ice ages, while feedbacks like carbon dioxide levels amplify the changes. This combination explains why the 100,000-year cycle has been so dominant in recent geological history. The conclusion of modern science is clear. Earth's history of ice ages is not endless chaos, but follows a repeating order set by celestial mechanics. We live in an interglacial period called the Holocene, which began about 11,700 years ago. Without human influence, the next glacial cycle would likely begin in roughly 10,000 years. But if the ice ages were gradual changes, then how is it possible that an entire civilization was wiped out, along with everything they had built, leaving us only with records of what happened after the Ice Age? For hundreds of thousands of years, Earth was home to large mammals that roamed across continents. In North America, there were mammoths, mastodons, giant ground sloths, and saber-toothed cats. In Europe and Asia, herds of woolly mammoths and woolly rhinoceroses grazed the cold steppes. South America had its own giants, including armored glyptodons and oversized camels. Australia was home to massive marsupials such as diprotodons. These animals were well adapted to the cold, dry environments of the Ice Age. Yet, within a relatively short period of time, roughly between 15,000 and 10,000 years ago, most of them disappeared. The speed of this extinction has puzzled scientists. Fossil records show that species that had thrived for millennia were gone, in what appears, at least in geological terms, to be an instant. But how instant was this disappearance? That question leads us to one of the most striking and debated pieces of evidence from the Ice Age, the frozen mammoths of Siberia. In the permafrost of northern Siberia, explorers have uncovered mammoth carcasses preserved in extraordinary detail. Some of these animals were so well kept by the ice that their fur, flesh, and even internal organs were intact. A few were found with undigested food still in their mouths or stomachs. This has been taken as evidence that the animals died and froze so suddenly that the food they were chewing remained preserved. From these finds came the idea of an instant freeze. According to this interpretation, a sudden and catastrophic shift struck the region, dropping temperatures so quickly that animals grazing in the fields were flash frozen where they stood. Supporters of this theory sometimes suggest that a dramatic tilting of Earth's axis or a sudden climatic shock triggered by an external event might have caused such rapid freezing. However, mainstream science is cautious about this conclusion. The frozen mammoths are indeed remarkable, but their preservation may not require such extreme explanations. Permafrost environments can sometimes preserve carcasses if an animal dies in a mudslide, flood, or other natural trap and then becomes sealed in ice before decomposition begins. The presence of food in the stomach or mouth may simply show that death came quickly, but not necessarily in a single global instant. The disappearance of megafauna also raises questions about human survival. Archaeological evidence shows that early humans coexisted with these large animals for thousands of years. They hunted them, used their bones for tools and shelters, and painted them on the walls of caves. If so many animal species vanished in such a short time, could human communities have faced a similar fate? Some researchers suggest that groups of early humans may also have been lost during these turbulent centuries, leaving little trace behind. Explanations for the extinction of the megafauna remain debated. Some scientists emphasize the role of climate change, pointing out that the transition out of the Ice Age brought rapid shifts in vegetation, water levels, and habitat ranges. Others stress the impact of human hunting, arguing that even relatively small populations of humans armed with effective tools could have overhunted vulnerable species. Still others consider catastrophic events, such as the Younger Dryas impact hypothesis, in which a comet or asteroid may have triggered massive fires and sudden cooling. So, if great herds of animals could vanish almost overnight, is it possible that early human cultures could have suffered a similar collapse? One of the central themes in the work of Graham Hancock is the idea that ancient civilizations encoded astronomical knowledge into their architecture. These alignments were a way of preserving knowledge about the heavens. For Hancock, such monuments may represent not only local traditions, but also a legacy inherited from a much older lost civilization. Linked to this idea is the theory of the precession of the equinoxes. This is the slow, approximately 26,000-year wobble of Earth's axis that causes the positions of the stars to shift gradually over long periods of time. Hancock suggests that knowledge of this phenomenon may have been understood by ancient builders and encoded in their works. The monuments act as messages across time, reminding future generations of cosmic cycles that extend far beyond the scale of a human lifetime. Archaeological and archaeoastronomical studies have shown that many ancient sites do indeed display alignments with the sky. While interpretation vary, the repeated appearance of solar, lunar, and stellar orientations across cultures suggests that observation of the heavens was a shared concern among early societies. In many cases, alignments appear to mark important calendrical moments such as solstices and equinoxes, or to reflect significant constellations like Orion or the Pleiades. These constellations held special importance in many cultures. Orion, with its bright belt of 3 stars, was often associated with gods, heroes, or cosmic order. Its predictable movement across the sky made it a reliable marker of seasonal change. The Pleiades, a small but distinct cluster of stars, were equally significant. Their rising and setting were used by ancient societies as indicators for planting and harvesting, linking celestial cycles directly to agricultural life. The recurrence of these 2-star patterns in monument alignments suggests that ancient builders carefully observed the heavens and used the stars for practical guidance in organizing time and ritual. One of the most well-known examples is Stonehenge in England. This circle of massive standing stones has long been associated with astronomy. Archaeologists have noted that the monument is aligned with the rising sun at the summer solstice and the setting sun at the winter solstice. On those days, sunlight passes directly through specific stones, creating a precise visual marker of the changing seasons. A related example can be found in Newgrange in Ireland, a Neolithic passage tomb more than 5,000 years old. Each year, during the winter solstice, a shaft of sunlight enters through a specially constructed opening and illuminates the inner chamber. For a few minutes, the tomb is lit by the rising sun, the event occurring only on the shortest days of the year. This demonstrates an extraordinary level of planning and suggests that the builders intentionally aligned their monument to the solar calendar, marking both death and renewal through the movement of the sun. Perhaps the most famous case of celestial alignment is found in the pyramids of Giza in Egypt. The three largest pyramids are arranged in a pattern that many researchers have noted resembles the stars of Orion's belt. In addition, the entire pyramid complex is oriented with remarkable accuracy to the cardinal directions north, south, east, and west. This combination of stellar and terrestrial alignment has fueled long debates about the purpose and meaning of the design. Some interpret it as evidence of advanced astronomical knowledge, while others see it as symbolic connections between kingship, the gods, and the eternal stars. In the Americas, the city of Teotihuacan in Mexico offers another striking example. The Central Avenue of the Dead, along with the Pyramid of the Sun, is aligned with the setting sun during the equinox. Scholars have also suggested that the overall layout of the city reflects the positions of certain constellations, embedding the cosmos into the urban design itself. The Maya carried this tradition even further. At Chichen Itza, the pyramid known as El Castillo demonstrates a dramatic effect on the days of the equinox. As the sun sets, shadows fall along the staircase, creating the illusion of a serpent descending from the top of the pyramid. The serpent, associated with the god Kukulkan, embodies both celestial movement and religious symbolism. Other Maya temples were aligned with the planet Venus or with solar and lunar events. Even in North America, among the Hopi people of Arizona, echoes of this tradition appear. Studies have suggested that the arrangement of Hopi villages across the landscape reflects the constellation of Orion. This alignment, while less monumental than the pyramids or stone circles, shows how entire communities could be structured according to celestial models. According to the official consensus, civilization began about 6,000 years ago with Sumer, Egypt, and the Indus Valley. Before that, people lived mainly as hunters and gatherers. This view is based on clear evidence such as the earliest written records, city ruins, and dated artifacts from that period. Historians stress that extraordinary claims require extraordinary evidence. In other words, unless very strong proof is found, the timeline taught in schools remains the accepted one. By contrast, some researchers present disputed hypotheses. They argue that history did not really begin only 6,000 years ago because many ancient structures appear to be older than that timeline allows. To them, these monuments and artifacts suggest that advanced knowledge may have existed long before the first known civilizations. While these ideas spark curiosity, most experts argue that the evidence so far is not solid enough. That is why such claims stay in the category of speculation, not established history, at least for now. So, should we be afraid that the same fate which may have struck earlier civilizations during the last ice age could also happen to us? Could our own achievements one day vanish beneath sudden climatic change, leaving behind only fragments for future generations to discover? Modern science provides a careful perspective on this question. Researchers studying the Earth's climate warn that our planet is not as stable as it often seems. One of the most important systems is the Atlantic Meridional Overturning Circulation, better known as the Gulf Stream. This vast current carries warm water from the tropics northward, keeping much of Europe temperate and shaping weather patterns around the globe. If this circulation were to slow or collapse, it could trigger abrupt shifts in climate. Some models even suggest that such a disruption could bring about conditions similar to a new mini-ice age in parts of the northern hemisphere. Paradoxically, global warming may play a role in such a cooling event. As ice sheets melt and more fresh water flows into the Atlantic, the delicate balance of salt and temperature that drives the Gulf Stream could be weakened. Warmer air temperatures could therefore contribute indirectly to colder regional climates. Scientists stress that while a full-scale ice age is unlikely in the near future, sudden and extreme changes in climate are possible, and their effects on human society could be profound. The possibility of future upheavals has led some to wonder if history itself might be repeating a larger cycle. Some researchers outside the mainstream propose that the last ice age may not have been the only time an advanced civilization was erased. What if a civilization truly existed before the last ice age? And if it fell, then others may have risen and vanished long before it. In that light, humanity today might not be living in the first chapter of civilization, or even the second. We could be part of a much older cycle, one of growth, collapse, and rebirth repeating across ages. The story of the Ice Age isn't just glaciers and extinctions. It's a reminder of how thin the line of civilization can be, a line ancient societies may have crossed many times. Whether we are the first or simply the latest remains unknown. Science offers patterns. Myths preserve memories. Ancient structures raise questions. And until the next discovery reshapes our understanding, the Ice Age stands as a silent warning that history may stretch far deeper than we imagine. If this journey sparked ideas or theories, share them below. And if you think more people should explore the mysteries of the Ice Age, like the video and help spread the word. Stay curious, and until next time,